Welcome. Today, we're looking at the exciting fields of combinatorics and graph theory, areas of mathematics that are buzzing with activity and recent breakthroughs, particularly in 2023. These disciplines help us understand structure and relationships in complex systems, and the progress is quite remarkable. One of the biggest stories comes from Ramsey theory. Think of Ramsey numbers as guarantees. How large does a system, like a network or graph, need to be to ensure a specific pattern emerges? For decades, improvements in estimating these numbers were tiny. But in 2023, we saw the first exponential improvement on the upper bound for the classic diagonal Ramsey number RTT since the 1930s. Essentially, researchers showed R of TT is less than 4 epsilon raised to the power of t, which is a huge leap. Shortly after, another major result determined how the off-diagonal Ramsey number R4 grows, finding it increases cubically with t. These findings give us a much clearer picture of how order inevitably arises from chaos in large enough structures. Extremal combinatorics also saw significant advances. This field asks about the maximum or minimum size of objects with certain properties. A notable 2023 result, achieved using novel computer science techniques, drastically improved the upper bound on the size of integer sets that avoid any three-term arithmetic progressions. Think sequences like 3, 8, 13, where the difference is constant. Progress was also reported on long-standing challenges, like the sunflower conjecture, which deals with families of sets that intersect in specific ways. New techniques like the polynomial method and absorption methods are proving very effective here. Shifting to graph theory, the development of new tools is expanding its application dramatically. Graph neural networks, or GNNs, are a game changer, allowing machine learning algorithms to work directly on graph-structured data. This is boosting areas like social network analysis and bioinformatics, helping us understand connections, predict links, and find communities within complex networks. Techniques for graph embedding, which represent parts of graphs as vectors, are also enhancing analysis. Spectral graph theory, using matrix properties related to graphs, continues to yield deep insights, and the study of temporal graphs, graphs that change over time, is rapidly developing to model dynamic systems more accurately. Structural graph theory is also advancing, with new results on fundamental properties like graph coloring. For instance, recent work determined the fractional chromatic number for certain types of graphs. Research also continues into understanding graph structure by forbidding certain subgraphs or using tree decompositions, revealing more about how local properties influence the overall structure. Across both combinatorics and graph theory, probabilistic methods remain essential, offering powerful ways to prove existence and understand random structures. The interplay between random and deterministic viewpoints is incredibly fruitful. In summary, it's a vibrant time for combinatorics and graph theory. Landmark results on classic problems, combined with powerful new computational and theoretical tools, underline their dynamism. Connections to computer science, number theory, and other fields continue to spark innovation and open up new frontiers for exploration. Thanks for tuning in.